Welcome to the lecture 17 of machine learning course. In this particular session, we are going to talk about more about the decision trees and a new topic that is called the random forest. So decision tree is not a new topic for you. We have also discussed something about the last class. Once again, I want to iterate you that this is one of the very important machine learning model that the people use whenever there is a question of interpretability. Means if you want to interpret that what is happening underlying into the model, that is very much needed. You know that, for example, if you have a model and this model does some kind of classification. For example, somebody goes for a medical treatment, and that particular model is telling that looks like that you have a particular kind of problem. So how come this decision has been arrived by this particular model? If you want to understand that particular part called interpretability, so for those kind of things, decision tree is one of the best model, and most of the time people want to use these kind of models. So in the last class, we have seen that it is nothing more than this, that there is some tree-like structure, and at every node you are going to test something. So this particular node tells that in our database what is the value of overcast. So it and the branches actually represent that what are the values available. So outlook could be sunny, overcast, or rain, and based on that, you are actually going to divide the database into the two parts, and you are going to further find out that how to go ahead with this. In the last class, we have seen that how mathematically it represents the disjunction of the conjunctions, and we have also seen an algorithm that is called the ID3 algorithm to find out a decision tree. Here, very important part was this, that somehow we want to find out the best classifier. Okay, so we want to find out the attribute that is a best classifier for the examples. In the last class, we have seen that one such method is going to be the information gain. In the last class, we have seen that one such method is going to be the information gain. What is the information gain? Information gain can be obtained by using a special kind of notation that tells that, for example, if this is what my data is, and I want to design something, for example, as sunny. So see all those data examples where the value is sunny. You can see that D1, D1, D2, D8, D9, and D11. These places the value is sunny. Out of them, you can see that how many of them are positive and how many of them are negative. And using this information, you can find out that what is the entropy of this particular database. So if you want to find out the information gained with respect to a particular attribute, you have to find out all the values that that particular attribute takes. And in all those cases, you see that what is the size of this particular set SV. Divide by the S, that is the total number of item over here. In this particular case, it is 14. And find out the entropy that I just talked about, that plug in the value of entropy over here for all the possible values. And you subtract the summation from this particular interesting quantity, that is the entropy of this complete database. And you know that what is the entropy? Entropy is the formulation that say that find out the summation of pi log of pi. If you do this particular way and find out that what is the entropy for each of them. So here is an example that actually talks about that how to find out the entropy for how to find out the information gain for humidity, information gain for wind, and this is what the computation that we have done in the last class. We have seen that if we find out the information gain for all the attributes, the outlook is going to have the highest value. So we are going to put the outlook at the root place, and then based on that, this complete database is divided into three parts. This is the first part, this is second part, and this is the third part. This particular part is actually pure because all the examples are actually positive only. So we need not to go ahead, and we can say that if outlook is equal to overcast, then the answer is going to be the yes. For all other cases, we have to apply out of the available attributes. What are the available attributes? Humidity, temperature, and wind. And we again find out that what is the value of the information gain on this particular database, that is a smaller database. And we have seen that if you can find out the largest value is 0.97, and therefore you put again the humidity. So by this, if you again do the same kind of thing, you are able to find out this particular tree we have discussed in detail in the last class. Again, the question comes that let's assume that you have this particular decision tree. Then, if new example comes, outlook is equal to rain, humidity is equal to high, wind is equal to weak, then what is the classification for that particular thing? We have seen that it's very easy because you want to find out outlook, it is rain, so you come into this particular direction. Then you want to find out the value of wind, that is weak, so you come into, I think you come into this particular direction, and therefore you get the what is the classification, that is S. Very important thing that in this particular example we have seen that there are missing values. You don't have the value of temperature, missing values, so the value of some of the attribute is not specified. But even then, this particular tree is built, in our case is built in such a way that it can provide you the right classification. So hope that is clear from the last class. Today we also want to tell you one more attribute selection method, that is called the Gini index. And Gini index is nothing more than this, that instead of using the pi log pi, it says that Gini value is the probability square. So there is also a very similar term that is called the Gini impurity or the Gini index. So this Gini value is actually subtracted from the V1, then it becomes the Gini impurity. Gini impurity is going to take the value between 0 and 0.5. You know that entropy was going to take the value between what? 0 and 1. The maximum value was 1 and minimum value was 0. And when the purity of the class was 100%, then at that particular time, entropy was going to have the 0 value. Similar thing is going to happen over here. If you want to find out what is the Gini impurity, so for the pure databases, what is the value? For the pure databases, when all the items are positive or negative only, the value is going to be 1. In all other cases, it is going to be 0.5. So into the same way, you can find out that what is the value of on given a database, what is the value of Gini. So Gini value, as I told you, that you just find out that what is the summation of probability of that particular class square. So in this particular example, can you tell me that how many positive and negative examples are there? 1, 2, 3, 4, 5, 6, 6 negative examples. So probability of being being negative is 6 by 10. So square of this particular quantity, and then 4 by 10 to the square. So this quantity is going to be called as a Gini index, Gini value, and that is going to be 0.52. Similarly, if you want to find out the Gini impurity, you just subtract this value from 0.52. So that is not a big thing. Just try to understand that there is some value, Gini value. So immediately you can think, you can find out that finding out this Gini quantity is more efficient as compared to the what? The information gain or entropy. Why? Because entropy entropy needs pi log of pi. So this taking log is not that easy thing, because log is something that is exponentially you have to find out, and therefore either you go for the approximation, then you have to find out the summation of multiple terms. However, the finding out the square is very cost effective and fast. So let's assume there is a very important thing. Please note down, because we have a database. We can find out that what is the Gini value. You immediately can find out. But our target into when we are going to define or make a decision tree is that given the database, we are going to divide into two parts and want to find out whether this particular division is better or this particular division is better. Multiple divisions we can come up, and then we can find out that which particular division is better. And division is done based on what? Attribute. If you want to test the attribute values for the items which have this particular attribute value, you are going to say that these items are going to be into one category and another category. Let us investigate two cases where this particular the same database has been divided into two parts, where I can say that first one is A, another one is B. 10 items were here. So the A contains how many? 1, 2, 3, 4, 5, 6. 6 items. One A contains 6 items and B contains 4 items. So can you find out what is the Gini value for A? Again, using the same formula, 1, 2, 3. So it is 3 by 6, because 6 items is square, plus 3 by 6 to the square. So it comes out to be 0.5. What is the Gini value of the B? 1, 2, 3. So 3 by 4 square plus 1 by 4 square. So it's 0.625. Now, if you want to find out, now that is, I'm going to tell you important thing, and that is a new thing I'm going to tell, that if you want to find out that what is the Gini value of this particular split. So this particular and split is underlying being understood that this split is going to happen with respect to the attribute. there is some attribute with respect to that this particular split has been happened. So with this, for that particular attribute, if you want to find out what is the Gini value, then it actually says that you find out the weighted summation of these two quantity. What is the weighted summation? 1, 2, 3, 4, 5, 6. So it is 6 by 10 multiplied by 0.5. 0.5 plus what? How many items are there? Here 4 by 10 multiplied by what value? 0.625. And it comes out to be 0.55. Into the similar way, if I give you another example, this particular split that is going to happen maybe because of the testing on the different kind of attribute. So what is the Gini value over here? Again, you can find out what is the Gini value of A, that is 0.591. Gini value of B 0.55, and Gini value of that particular split is going to be 0.580. So can you tell me which particular split is better? Anybody? Split first split or second split? Because let me say that this is the split number 1 and this is the split number 2. Which split is better? Can you tell me? Can anybody write? Second one, because it has a higher value. So this is a better one. If we find out the second one is a better split, please note that we have used this particular Gini value. If you use this particular quantity, means in this computation, if you say that 1 minus the value, 1 minus the value, it is not going to have any different thing, but it is going to tell you the Gini impurity value, and then the item which has the lower value becomes better. However, we are going to use, since we are using this particular quantity, so higher is better. So this is another way, and let me tell you that this is more used method, and one of the very important reason for doing this thing is this, that computationally it is easy as compared to the finding out the entropy. Make sense? Okay. So we have last class we have seen that there are, when you are going to develop a decision tree, there are few issues that actually pop up. For example, how deeply to grow. If you grow this particular tree very deep, it, so then what would happen, that on the complete database your things are going to be completely correct, and therefore the chances of overfitting actually arises. We have seen into the, when we are studying about the concept learning, we have learned that something that is actually 100% correct on your database, definitely it is going to do the error, and that error would be only done on the where, or the new training examples. So that's why even if we want to be somehow bad on this, so that the thing which is better on the unseen example, we can obtain those kind of things. Also, we have seen that this particular setting in which we are right now, it actually uses the only discrete values for attributes. So what would happen, that if they are a continuous value, for example, if there is a attribute such as weight, so weight, you know that it can be any value. Height, okay. If we say the gender, then it is another thing. You can say that male or female. But if it is height or weight, then it can have any value 32.5 kg. Then how can you utilize this thing for the decision tree? Because in the decision tree, every node you have to test, and then for multiple branches you have to create. How to go ahead with this? Again, a good question. Choosing appropriate attribute selection measure. We have seen two till now. So there could be other cases where maybe some other thing could be more appropriate. We are going to see these things. Missing attribute value, what to do for that. Attribute with a different cast, what to do with that. And ultimately we want to improve the computational efficiency. That is another thing. So till now we have seen an algorithm. That algorithm was ID3. Everybody knows this algorithm or not? Everybody knows this algorithm, ID3 algorithm? Yes, because this was the algorithm that we have just discussed. It has a name, ID3 point. This algorithm, ID3 algorithm. That this was the algorithm, ID3 algorithm. So there is, after a few years, the same peoples have given another algorithm that they have named again into the similar fashion, very interesting name, C4.5. C4.5. This algorithm was given, and this is actually able to handle all these things. Make sense? So in this particular class, we are going to see that particular algorithm, that what to do that if these kind of scenarios are arising. Make sense? So for a few minutes, let us talk about the very interesting topic that we have just a few minutes back we have touched upon, that what is overfitting. Overfitting, what happens, that overfitting means very becoming good on your data. So let's assume that you have some database. Okay, let's assume that you have some database. On that database, you are developing a tree. and the size of the tree is going to be plotted onto the x-axis. So if you increase the size of tree, means your tree is going to be better on the data. Yes or no? What would happen? Your accuracy is going to increase when number of tree nodes are going to be increased. Your accuracy is going to be increased. At some time, you may be reaching to the maximum, whatever is possible. But what would happen that on the training data, okay, this is on the training data, but what would happen on the test data? On the test data, on the test data, your accuracy is going to be reduced. Your test data, your accuracy is not going to be that good. Okay, on the test data, your accuracy is going to reduce as you are going to increase the number of thing. Why? Your tree becomes powerful, but it is less generalizable, and therefore for new thing it is bad. So here is an example. If you want to say that what do I mean by overfitting, so here is an example. Let me give you this. Let's assume, please everybody concentrate. I would ask a question, sir. What does Gini value tell? So Gini value tells that how much difference between those values are. Okay, how what is the disparity? How much disparity is there? So the Gini value is actually taken from the economics domain. Many people maybe who have some background in that, they may know. Into the word, if you want to find out that how much prosperity is disparity in the prosperity is there. Okay, so you want to tell that richer peoples are more richer and poorer peoples are more poorer. What is the difference? How much difference between them are? So this particular quantity is being represented by the Gini value. Make sense? Okay, so let me tell you that what we are discussing. We are discussing. Let's assume that you come up with a hypothesis. As please concentrate on this particular point, and let's assume that its accuracy is 100% on the training. On the training data, its accuracy is 100%. But if you go for the test data, its accuracy is found to be, let's assume that 55%. This happens because you know that the accuracy on the test data would be lesser. So this is what the general scenario is. Let's assume that you are into this particular scenario where you have a hypothesis that has a training accuracy of 70% and testing accuracy of 55%. Now I am going to ask a question. Let's assume that I give you another hypothesis H dash whose accuracy is 65% on the training. So is it a good hypothesis? Answer is no, it is not a good hypothesis because its accuracy is lesser than the 70%. So how come it be good hypothesis? Make sense? Everybody, H dash is a good hypothesis? Answer is no. Whether H dash is a good hypothesis, whether it is a good hypothesis, answer is, can you tell? No. Are you agreeing with me? That is not a good algorithm because its accuracy is how much? Only 65%. So it is not a good hypothesis. But if I tell you this more information, that on the testing data its accuracy is 59%. It is very difficult to tell because this data is nobody has. But let's assume that I somehow tell you that accuracy on the test data is 59%. So whether H1 is better or H2, now you would tell that okay, forget about this particular value. If things which are better on this particular testing thing is going to be better, so now you would tell that H dash is better. Okay, H2 is better. Second hypothesis is better. So this is what the meaning of the overfitting, that when you say that your things are not good on the testing, if the things are good on the testing, then it is not a overfitting thing. That higher accuracy on the training but lesser accuracy on the testing is called the overfitting. Okay, so what are the approaches to avoid overfitting? How can you reduce the overfitting? What could be the approaches? One is the stop growing. Means if when you are actually having the tree, you stop growing after some time. You say that I would not increase the size. Okay, so how can you do that? What is the handle? How would we understand that what is the right time to do that? The answer is this, that if you have a database, and the database is actually generally what we do, because into the machine learning we for the practical purposes we have to do it, otherwise all the data what is given to you you should use for training. But here what we do, that we divide the data into, for example, 60% of the data is going to be used into the training, 10% of the data into the validation, and rest of the data in testing. Okay, so what do I mean by this? I mean by this that use this particular thing to build your model. Okay, so you are going to build your tree. So you have actually used this thing and built the complete tree. Okay, you have built the complete tree on that, so that 100% accuracy or 99%, whatever best accuracy you can achieve, you can achieve. But you have now, your task is, please focus, now your task is to test. Now your task is to test on these particular examples, which are the validation example. When you test it, you find out that accuracy comes out to be 75%. So I say that, is it possible that if I remove this particular part, if I remove this particular part, whether my accuracy is going to increase? So you may be knowing that if I remove some of the part, you know that if I remove some of the part, accuracy is going to change. So if it can change, so it can be better or worse, anything could be possible. So if I am removing this part, there is a chance that my accuracy could be better. It could be greater than 81%. If I find out the right place to remove, my accuracy again can go to the 83%. So by this I would increase my accuracy. And on this, on again on the testing, the accuracy actually was, testing accuracy was 99%. It may again becomes 91% or so, because it may reduce. But on the validation set, which was actually 75% with the 99% accuracy, now it is going to be 83%. It is a better than that. So if you can cut some of the portions, so this, the remaining portion of this particular tree, remaining portion of this particular tree is going to be served as a your learned model. Makes sense? And now you are going to use on the testing and tell me that what is the accuracy on that. On the testing data, the accuracy could be maybe low, maybe something 85% or 81%. Anything could be possible. So this is the way that we do. So this is the method that is called the post pruning. Means when you develop the tree and you say that I would not after that, after developing the thing, you are actually pruning the thing, some are removing some of the parts and using the validation set. You are going to do the pruning by using the validation set. Another method could be that you develop some of the statistical tests, such as chi-square test, and these tests, using some of the tests, if you can predict in some way that if this is the tree, what is the expected value? 1 minute. If this is the tree, then what is the expected? Yes. What is the expected value of the accuracy, expected accuracy that is going to be on the test set? So using the tree that you have, you develop some of the tests that can tell you that what is the test accuracy going to be. However, it is very difficult to find out such tests, but some tests can suggest these things and you can utilize them. Another method you can utilize, such as explicit measures, such as we have talked about the maximum description length in the previous class, that actually try to understand that whenever you have a hypothesis, or because ultimately you know that this particular trees can also be converted into the hypothesis, you find out that how much how much this particular hypothesis is able to compress the data. And then if you are going to add more nodes into this particular tree, then definitely for how this particular action is going to affect your compressibility. If you are actually able to compress, then you have to go ahead, otherwise you may stop. All these things are clear to you? That one way that you use validation set, using that thing, when you develop your model completely, then after some time you cut those parts. Second method, you use some of the statistical tests that may be dependent upon some of the earlier seen things, and you can utilize that thing to find out that what is the expected test accuracy, and using that thing you can tell. However, it is very difficult to come up with these kind of functions. Better method could be that you use some kind of information theoretical views, such as maximum description length or any other theoretical methods that can tell you that how good your particular learned model is based on those kind of metrics. So if you are going to improve that particular metrics, then you grow, otherwise you stop. Three methods by which you can stop these kind of problem. So ultimately, for example, if you want to go to focus on this particular part, then it is something called the reduce error pruning. Because when you have a tree and I'm going to tell that remove this particular part, so if this particular pruning you are going to do that, if your error is actually reducing, Okay, why you? How come you can cut this particular tree part? You can only cut this particular part if your error is reducing. On what? Validation. Validation set, if your error is reducing means your accuracy is increasing. Your accuracy was initially 75%, then it becomes 81%, then accuracy becomes 84%, means error is reducing. If your error is reducing, then only you can do all these kind of thing definitely on the validation set. Okay. You do it in an iterative way means you are removing something, then removing something. Iterative way, multiple thing. Initially in this particular tree, you are removing this thing, then after some time you are removing this thing, this part, and ultimately the remaining thing would be there. So some parts are actually deleted. So if you do that, so a few minutes back that the curve we have seen, that this was the curve that actually you when your tree was growing, then your on the testing accuracy, this was the error going on the training thing, this was the error. Train. On the testing thing, you know that the accuracy is going to reduce. But if you do these kind of things that we have just seen, that whatever tree you have, you are actually going to cut some of the part, then what would happen? That focus on this particular part. Then what would happen? That if this was your accuracy, it becomes this. Because of this was your accuracy becomes this. This was your accuracy becomes this. If you remove those parts, reduce error pruning, if you do the cutting into the tree, your accuracy actually increases. So instead of this particular curve, you are going to have now this particular curve. Make sense? However, there is a small drawback into this particular approach, that you have to use a validation set, and since number of examples that were given to you, you are going to keep some of the thing for validation. So number of things that are used for the training is actually get reduced. And most of the time the number of training examples are not extremely large, so therefore it becomes very difficult to go ahead with this. So if separating this thing is not a sometimes becomes not a good idea. However, this is the only thing that you have to understand, that if you are actually separating something for validation set, this kind of problem could be there, that you have actually less data for the training. Okay, so another method is called the rule post pruning. That is also an interesting idea. You know that if you have a tree, so you can represent this as a hypothesis in this way. So here what you can do, that when you have this kind of, for example, humidity is equal to high, you can say that you can put a question mark over here. So if you put a question mark, it is a more general way to represent. So it would give it is going to be simplified. So it may be possible that by putting this question mark, you may be getting a better hypothesis. So this is what the rule post pruning, that tells that whatever hypothesis that you are going to obtain by this particular tree, you are going to do some kind of generalization on that, and then you are going to see that what is best. And definitely whenever you are going to generalize do the generalization, again you need a validation set to tell that if I am going to do this generalization, whether this generalization is going to improve, or it is beneficial for me or not. So again validation is needed over here. So C 4.5 algorithm that we have just I have just given the name. This particular algorithm can handle the continuous value and missing values, and pruning trees after the construction. It can apply the pruning trees. So one one way is this, that it is a very strange kind of idea, that is a pessimistic estimate, finding a pessimistic estimate. And for the, again it is the same thing that we have talked about, that if you have a tree, you want to somehow find out that using this tree what is going to be the uh, test accuracy. So there is, I don't know, we are not talking about that how to find out this, but if you can find out some method that given the tree, given the data, can tell you that what is the accuracy could be, then you can utilize that thing for actually telling that I will not grow the tree further. Make sense? However, it has been uh, observed that if you have the large databases, then most of the time your pessimistic estimate is going to be correct. For the small databases, things are not going to be like that, because you know that if lot of data, if this is what all the things are this, and I give you this data, and you want to come up with a model, instead if I give you this data, then your model would be more correct. So if the large number of data is there, then pessimistic estimate kind of approaches you can find out. Okay. However, this is a heuristic based method that is not statistically valid, and it is very difficult to come up with these kind of things, as I told you earlier. So this is one method. Okay. So let us one by one see that all the things that it can solve for us. Continuous C4.5 algorithm, how it suggests that how to handle continuous value, missing values. So for the pruning, we have seen that this is one method, and multiple methods we have seen. So let us see that how you are going to handle the continuous valued attributes. Okay. Once again, what is the continuous values? For example, if I put age or income, all these things are going to have the value. So definitely I would be having into the trouble if I'm going to not convert them into the categorical value, because then I cannot apply my tree algorithm over there. So one direct method that can come in your mind, that you can apply, you can use a threshold. If the value is less than that threshold, you say that I'm going to use this as a low, otherwise I would say that particular value as a high. So let us understand by using an example. So let's assume that there is an attribute called temperature. Okay. And there is a target attribute. Let's assume that a plate tennis. So two attributes, let's only two things are there. One is the target attribute, and another is the attribute that is given to me. So what is the value of temperature? Temperature could be anything. So let us assume that okay, one thing that I wanted to tell you, that I have put these values into the sorting order. So that doesn't make any difference, because if the data is given to you and the values are not sorted, you can sort it. It doesn't give you a different database, same database it is. So for just without loss of generality, we have actually sorted all the values. So what I can tell, that if I can take this particular value as a threshold, that is, I can say that threshold of 4860, for example, let's assume T4860. So I say that these value as the temperature is low, and I can say that if these value at temperature at high. So I can say I can convert these numerical values to the categorical value using low and high thing by using a threshold, for example. So if you again if you apply the threshold over here, so this is a one database, this is a second database, this is the second part, and then this thing becomes categorical because it is low and high. Then again you can find out what is the gain on this particular attribute using this kind of difference, this kind of using this kind of methodology. So if you divide them into the two parts, and then you can again find out that what is the gain on this particular with respect to that particular split. So once again, what is the entropy of this particular data? You know that the number of negative and positive are actually same, so entropy is going to be 1. We know that. Is it 1? Yes, because when number of positive and negative examples are same, then this value becomes 1. So let me partition it around 44. This is value T44. When I partition around 44, then this is the low value and this is the high value. So I divide the data into this way. The first part, that is 0 positive and 1 negative, and the second part has 3 positive and 2 negative. I can apply the same methodology to find out this value, that is the entropy. Entropy of this particular database comes out to be 0.29. Is it entropy? Entropy of this particular database having the entropy is 0. Okay, this part entropy is 0.29, and for this part the entropy is 0 because everything is only negative. So if I apply into this particular formula to find out the gain, it is going to be entropy of the complete database, that was 1. Then the summation of the two quantities, what are the values, low and high. For the low and high, I have to find out these values, low and high. What is for the low? The entropy is, it is 0 multiplied by 1 by 6, because how many items are there? Probability buying is 1 by 6. Probability of coming over here is 5 by 6. And what is the entropy? Entropy is this value, sorry, 0.29 and 0.29, and therefore you find out the computation as 0.243. So this is one value. So multiple places you can split. You can split here, you can split here, you can split here, you can split here, you can split here. So all the places, if you do in the similar way, you find out that what is the entropy, the value that this the split that actually maximizes this particular value, you can take it as a separator for these two kind of things. Okay, for these kind of values. So this is an example. Next thing that I want to talk about is about the alternate measures for the attribute selection. That is why it is important. We have seen two things, na? Gini and what? We have seen Gini index and what? Few minutes back we have seen. Can you write? Information gain. So we are going to see few more things into this particular session, and let me tell you that why they are also required. Okay, information gain favors attribute with the many values. So if there is any attribute that have many values, it favors that, and it has a higher value for that. For example, in a table, if there is a attribute called date, you know that date would be always different. So for date, the information gain is going to be the highest value. So what would happen every time you are going to put the date over here, because you know that if you know the date, then you know that what is the yes or no. So definitely it is not a good thing, because you don't want to put the date at this particular place, because when a new data item is coming, it would not have any other date that is available into your databases. So you would not be able to go ahead. So you want to do something else. So for that thing, a new item is a new kind of attribute selection measure has been supported, that is called the gain ratio. What is gain ratio? Gain ratio is you use the attribute that the gain that we have using earlier, but here it is telling that you divide by one more quantity, that is called the split information. And what is the split information? That how well this particular thing is splitting the things. And in split information is again can be computed using the similar kind of formula that says that for I is equal to 1 to all the values that it has, what is Si divided by S log of Si upon S. So it is again the similar kind of expression, but when you divide this, you are going to get the better thing to divide. Let me tell you that is here is also a very important problem when you are going to have this particular kind of thing. That if the split information, for example, gain ratio is a good thing that actually tells that things which are balanced, they would be getting good visibility for going to be put as a root. But here again there is a problem that if the split information is very less, okay, very small, then this gain ratio becomes very large. Okay, for some attributes, if this value is very small, then they are getting more favor. So it is being told that it is being suggested, for example, if let's assume that 1 2 3 4 5 6 7, let's assume these attributes are here, and they are the, and let me write them into this increasing way. Let's assume that some has this 6 point 0.6 to 0.7, 0.72, 0.4, 0.3, 0.12, 0.10. Let's assume that these are their information gain. So which attribute you are going to select? You are going to select this attribute. But I'm telling that don't select this attribute, because it may be a trap that this has a lot many number of different values, and that's why it is being selected. So the idea is this, that you just now we have discussed the idea that instead of using information gain, what you have to use information the gain ratio. That is, you have to use the gain ratio. And what is that? That is the this gain value divided by some split information. So you are going to compute another value that is a split information, and you are going to say that this value divided by split information, and then you are going to, based on that, you are going to find out the right value. But what I wanted to tell you, that this particular method says that don't find out the split information for the items which are actually having the very less value. So for these values, don't compute them, because this kind of problem when the split information is very less can arise for only these kind of cases. So you don't evaluate on these kind of values, you only evaluate the things over here. So for the 50% R case, you if the split if the information gain is larger than some threshold, then only you apply the method and find out what is the right value. So very interesting idea. that please read this, that they tells that for not for all the values, not for all the values, only select for the see the items which have actually have the higher information gain, for then only you find out the gain ratio, and then out of them you select the best one. What you can do with the missing attribute value, if you have something that attribute has does not value, what you can do? Okay, so you may think that, for example, if you have a database and there is a lot of values are available, there is some attribute with respect to this, let's assume that this value is not available. What would you do? One method says that you find out that what is the most expected value. For example, if you say that how many, let's assume that this contains 0 and 1 only, see that who is, whether zeros are more or ones are more. If ones are more, you put that value over here. One method says this particular thing. Makes sense? But however, this is not a good method, because sometime your database may be a specific database. For example, if this database has been collected into the medical domain, and this, let's assume that this is only the data of the people who have the diabetic. So, and this is, let's assume that this value says that what is your blood sugar level. If somebody, for example, if you goes to the medical list to the doctor, he find out, okay, do you have the medical report? So you say that, sir, I have not tested my glucose levels. So he would tell that, okay, in the database, find out what is the maximum value. It looks like that the maximum value is 150. He puts this value over here. So you become diabetic immediately. It was this is not a good thing, because you cannot put this value over here. Make sense? Make sense? So you cannot put the value into this particular way. However, sometimes people use this, but this is not a good idea. Another good way is this, that you consider all the possible values. For example, as I told you that for the attribute 0 and 1 were possible, I say that 0. Say it is 0.7 probability that value is 0, and therefore 0.3 probability that the value is going to be 0. So you assume, for your case, for whenever a new data is coming, you assume this value to be 0. You assume this value to be 0 and find out that what is the probability, what is the classification. Let's assume that it say the classification is 0. Okay, for the second item, you say, second time you also evaluate by putting the value 1 over here. Try to see that what is the classification. If the classification is 1, if the classification is 1, you say that because it was 0, so the weight is only 0.7. With the 0.7 it is 0. With the 0.3 it is 1. So you say that the looks like that the item should be 0. For all the possible values, what I'm going to tell, for all the possible values, you fill these values at this particular place and find out that what is the classification, and attach this particular probability to this particular classification, and then find out the summation for all the available labels and give me the label that maximizes the value. Make sense? So one strategy is to use the most common, but that is not good thing. So I say that assign a probability to each of the possible values and find out that what is the value, and then you can use that thing. Also, there is a problem when, for example, we have talked this into the last class, that there could be a problem when there is an attribute with a different cost. What do you mean by this? That some attribute may have a different cost. For example, if you are going to the doctor and doctor asks that what is your temperature? Okay, what is temperature? What is pulse oximeter? What is pulse oxygen value? And what is, for example, your weight? And what is your glucose level? So if I ask all these things, you must think that doctor have a thermometer, he can immediately put in your mouth, find out that what is the temperature, what is pulse oxygen. Everybody have the pulse oximeter, and he can find out value. Weight, there is a weighing machine, you stand and you can find out these values. How much they are costing? Let's assume the 1 rupees. But if you go for the glucose test, it is going to take you, for example, 200 rupees. So this test is very costly. So even if it is very accurate, you should not put this thing at the top. Okay, because if somebody is coming, he may not be able to afford this thing for some of the reasons. So try to have, if there are attributes that have the different cost, you cannot make the things into the same way. You have to do something else. So one method is this, that you can divide the gain by the cost of the attribute. So if it is like that, divide the gain by the cost of the attribute. One method is this, that whatever gain you have achieved, you divide by the cost. Okay. This was the one method. Another method is actually Tan and Slimmer has actually had the robot perception task. And what the robot perception task? That there was a the task was this, that there was a robot and there was in a box some item was there, and robot was going to tell that what is the item into there. There are various sensors, so you can say that there is a camera, there is a sonar, there is a different kind of sensors available. So different sensor may have different cost, because some fast camera may have larger cost as compared to a smaller camera, or any other things. Different sensors have a different cost. So if what particular thing he have, what particular sensor he have to give more weightage. So what he have used that, use the information gain square divided by the cost of that particular sensor. He told that if I use this particular value, it is going to give me a better thing. Okay. Nonji, etc. actually have done an experiment into the medical diagnosis, and they have proposed that if you put the value 2 to the power of information gain -1 divided by cost of that particular experiment -1 to the power w, where w is some value between 0 and 1. So this is a better way. So as I told you, that when the things are going to have the different when the different attributes are going to have the different kind of kind of cost, then either you can divide by the gain, either you can square divided by the cost, either you can 2 to the power gain -1 upon cost plus 1 to the power w. So different models are there. You have to experiment and find out that what is the best suitable for you. Make sense? Because now we have not only the one criteria, we have two criteria. We also want to reduce the uh, attribute evaluation cost also, because this can be done, as you know, that because of my decision tree model I can do it, because if I can find out the classification here itself, I need not to go deep down and do all these kind of experiments, all these kind of tests. So this is another thing, that when you have the things with the different cost, we have seen that what to do when the missing values are there. Now I'm going to tell you a very important concept, that is called the random forest. So all of you are with me? I need yes. Okay. Let me show you a database. Let's assume that I have a database. Okay. All these values are there. So can you see this? So in here, lot of rows would be there. Lot of columns would be there. Everybody say yes. Can anybody say yes? Everybody understand this? Yes. Ravi, can you say yes? Yeah. Okay. So what I wanted to tell, that what would happen that if I say that I'm going to remove, I'm going to delete these these two attributes. So I would be getting a different database, D dash. Okay. What would happen that if I say that I'm going to delete these few of the uh, rows, I would be getting a different database, D double dash. So let's assume that there are small m number of rows, and how many attributes? N attributes. So I can remove any of them, but not all. So 2 to the power m plus n number of thing I can remove. Okay. Because I can also, because it is also allowed. Everybody, if you don't understand, please ask me. I can remove this particular attribute, and I can remove these items. So how many different databases I can create? 2 to the power m minus 2 to the power m plus 1 minus 1, because if I that would include one more case when everything is deleted and no database is there. So that's why I'm telling -1. So these many databases are possible. Make sense? This part is clear to everybody. From one database, how I'm going to create the different database. Everybody is clear? Ravi? Gauranj? Okay. So I'm telling that if I'm going to, this was the database. From this database, I deleted something, I deleted something, I deleted something, I deleted something. I have created multiple databases. This everybody understand. I have created multiple databases. From this database, I have created multiple databases. Now I am telling that I am going to create the decision tree on all of them. different decision tree. So how many different decision tree I can create? 2 to the power m plus n minus 1. Ooh, this is going to be a very large number, but let's assume that I have created very less number of, say, yeah, with this database I have created 1,000 different databases, randomly deleting some of the attribute and the items. Okay, 1,000 databases. Then how many trees I have? 1,000 trees. So one tree is tree, 1,000 trees means forest. I have randomly created, so it is a random forest. Okay, all right, I have done this. But what is my objective? Objective is this: that when a new example is coming, how I should be able to tell that what is the classification of that particular item. So classification of that particular item would be obtained by consulting all the available trees. I would find out that what is the classification. I would find out what is the classification for all these 1,000 trees that I have created. I would ask that what is the classification. Let's assume 700 of them are telling yes and 300 are telling no. Then can you tell me that what is the classification of my item is? Yes or no? Can you tell me? 1,000 trees I have created. Out of them, 700 are telling yes, 300 are telling no. What is the classification? Sanidhya? Yes? Okay. So this actually what happens now, whenever we are collecting the data, a lot of data errors can come. But after doing these kind of randomizations, those things actually get compensated many of the time. And that's why the accuracy of random forest is very high as compared to the decision tree. And this is one of the most used method into the machine learning community. Okay, so we whenever a new item comes, we apply voting, and this is what the voting was: that how many of the trees are telling that it is yes, how many are telling that it is no, and this is called the voting. And based on the voting, I can tell that what is the classification of this particular item. So whether this concept is clear to everybody, the random forest? Clear? Yes. That from one database I have created multiple database. On one database, from one database I have created. From one database I have created multi database. For each of them I have created the tree. If a new item is coming, I apply voting, find out that how many of them are telling yes or no, and then I can tell that what is the classification of that particular item. Thank you very much. That's all for my side today.